Hey YouTube, Nick here again. Sorry, not gonna walk you around the truck today. Next video, I hope. Still working on it. Gonna build a bracket today and tomorrow probably. Actually, we're gonna use the time machine because it's the future right now and go back in time. Bracket's already made. But we're gonna do it for this, which is a Eaton PDM3. It's a power distribution module that takes your battery and distributes it amongst some of your higher current consuming loads. I have one on the main battery already, and it distributes power to the grid heater solenoid, the alternator, which is really going the other direction, but it's still fused on this box, and then also to my RTMR fuse box with all the relays. So what we're going to do is we're going to put this on the firewall on the passenger side and build a bracket for it. So let's take a peek. So the first thing to do when mounting something like this to your truck or car or whatever is to try to find an adequate spot. So I haven't put the air pump in here yet because I think I've already found a decent spot for this, and it's these 3 bolts there on the firewall. So I'm thinking the box will end up somewhere around there. I still have to run AC lines, so that'll clear those. I should be able to get to that panel and service any of the fuses and stuff. It might be a bit of a reach, but you know, that should be pretty few and far between. And then some of the fuse connections will go to the air compressor, and then one to the back of the truck, and then one to probably feed some of the accessories up here. I don't know where I'm going to put the next relay box, but it might end up somewhere along this section here. So the first step is to try and locate those 3 holes on a piece of paper. So this is a very exciting shot of a piece of paper. You can see I actually already marked them on here, but the process goes like this. You take a piece of paper, walk over to your truck or your car or whatever. See if I can do this one-handed. Press it up against where you want it to be, and then use your fingers and find the holes on the piece of paper. So there's one down there, and I push real hard, and then while I'm holding that one, I find the other 2 and I push on those. So then you'll end up with an impression of each of those holes on a piece of paper. So the next thing to do is to take a pen of some kind and try to, as best you can, brighten up those impressions that you see. Give you some decent marks on there. Don't have to be a perfect artist, but just a general idea. Something like that. And now what I usually do is I draw just a freehand crosshairs. Just like this. That one's a little off, but should be okay. Alright, so there you go. Now with an arrangement like this, always keep in mind which orientation it was on the firewall. So usually I'll put just like a little arrow that indicates up on there. And now we need to transfer this to either a piece of aluminum or a piece of cardboard, depending upon how good you feel about your design. One thing to remember is that these trucks were all made with some sense of engineering involved, right? So hole distances should be generally even, and also you should know the units in which to measure things. I mean, this is a Toyota, so it's obviously made in Japan, engineered there, so it uses the metric system. So if you grab, you know, a metric scale and try to line it up with the holes, you can kind of infer that that looks to be about 75 millimeters. So I would assume that the holes are 75 millimeters apart. And the same goes for these top 2 holes here. If I can get my ruler to move with one hand. line that across. That looks about dang near 60 millimeters. So given the inaccuracy and me pushing on the holes and maybe the paper was a little wrinkled, you can pretty much assume that 60 millimeters will get you there. So after you get your holes sketched up, go ahead and throw a scale on there and just see if you can infer what the actual measurements should be. That way maybe you don't even have to use what you've doodled. You can literally just take the bolt pattern or the hole pattern and put it straight onto a piece of cardboard if you want, and not have to handle or deal with these cross hatches that you may have put on there. Little tip. One thing to always remember when you're building brackets and stuff, or at least one thing that I do, is I always get out the hardware I want to use. So this is a Toyota factory 10 millimeter bolt. So I have one of these, which is going to be the 3 different locations on here. In order to attach the PDM, I have some, you guys are going to hate me for this, but I have some 5/16 bolts. The reason I'm not using metric is because I have a whole bunch of these lying around and I want to use them. And I use them whenever I'm going to be using riv nuts as well, because they're a matched set. I don't have to worry about finding the right nut for a bolt that's on my truck. So these bolts fit rather well in here. Pretty good quality too, so that's why I chose to use them here. But because the riv nut is going to go on the back of the PDM here, I need to make space for it, right? Because I don't know if you remember from the firewall, it's all flat. So if I just put these behind a flat piece of material like this, they'd basically run into the firewall as soon as I tried to install them. The next thing to think about is, how do I get these holes from a piece of equipment that you already own onto a piece of cardboard? Well, I'll use the paper again as an example. If I were to try to put these holes on a piece of paper, you could try to use a pen, right? These holes are actually pretty deep. The thickness of this part is deep, so finding the center of it, you might find a pen that's the exact right dimensions. This one is not. If I try to doodle a little circle, you can see there's a circle there, but did you have the pen perfectly straight, etc. I have different types of pens that I've used in the past. Let's see if I can find it here. I cannot. Oh, here it is. This one here. This is a long-nosed pattern marker, which typically is used for tracing things, but you can try to use that to make a hole mark. That's probably a little bit more accurate. So you end up with a larger one there. Or what you could really do, and this is probably the most accurate way of doing it, is with a set of transfer punches. So these are a dowel that's got a sharp point on it. Hopefully that comes through decently. And it makes impressions. So what you do is you find the right size for your hole. I've already done that. So this dowel is the correct size for this PDM hole. So then I'll place it on here, and you can just set it right in there, make a little dent, and then do it again. Make sure you don't move your part. And then you probably can't see them very well, but it made 2 little spots right here and right here, and they're perfectly in the center of those holes. So I know that if I use those as the starting point for a drill, that should be very, very accurate. One thing that I get a lot of questions about when people see some of the brackets that I've made is I usually do a lot of fillets around corners and stuff. There's usually not a lot of square pieces, and people ask me how I do that or how I pick those sizes. Remember our little bolt here. So this has got an internal washer on it. So in order to make things look purposeful, I want the part, which I imagine will look, have some rounded corners. Each one of these bolts that goes on these locations needs to have a a radius around it of the aluminum that peeks out, just so it looks like it was built with a purpose. And the way I do that is just by selecting some appropriately sized washers. So I'll take the bolt that I have, and this is typically the size that I use. It's a pretty decent amount of material around the entire circumference of the integrated washer there. And what you'll do is you'll take your washer and you'll place it over where your holes are going to be, and you'll just draw circles. Trace them. Doesn't have to be exact, as long as you're generally accurate. You can usually get a pretty decent looking part. So think about which direction the part is going to go, the edge of the part, and put your finger in a place where it won't be in the way, and just trace around your washer like that. So there's one circular location. This will be another one here, so I'll just line that up as much as I feel is appropriate. Just sketch around it. And then the last one here, like so. And this one actually won't even need any of the circular location, but the offset from the hole to the edge of the part, this should be straight now, at least generally straight. So I'll just use the washer as a guide there, and then I'll take a straight edge and I'll connect the tangents. So just line this guy up, extend it all the way to the bend line, and then this one here, line up the tangents, bring it there, and then this one will be straight across most likely, but I'll leave that empty for now until I figure out what the holes are going to look like for the PDM and where I'm going to mount it in relation to these mounting holes here. So that's how I get the radius look. Cut it on the bandsaw and then clean up all the edges, but that's how it starts. Change of plans. The original idea had that folded sheet metal design concept, and we're going to scrap it, and I'll show you why. So here's our handy dandy piece of paper, and what I realized, and I realized this as soon as I thought about building this, was we have 3 attachment points to the truck here, and there's nothing over here. So our little PDM will be flopping around the entire time. And I looked on this side of the firewall, there's nowhere I can attach this bent piece of aluminum. So what we're going to do is we're still going to keep those 3 points, but what we're going to do is we're going to overlap the PDM on top of them, and build a little standoff with a piece of aluminum tubing and then 2 plates, so that you bolt the plate to the firewall and then bolt the PDM on top of that. The good news is that we have basically the first bracket done. I'll just cut this out of aluminum, and I believe we'll be able to, like I said, just put a cut piece of this tube on there, TIG weld it all the way around, and then put another plate on top of it and TIG weld that on, leaving again enough space for our riv nuts, and then also enough space for us to gain access to put these bolts in and tighten them. But I think that'll still work. We've got plenty of space that I can see here. Probably still fit box end wrench or a ratchet on there. All right, so I decided to just trace the PDM onto a piece of aluminum. I did use the transfer punch to put little marks. You can see it right there for the holes. So each hole got its own transfer punch mark, and then that's where our little Starrett spring-loaded center punch comes in handy. These are somewhat expensive, but I think they're like 20 or 30 bucks. But it will pay for itself if you do any fabrication. Instead of using a hammer and a nail or a hammer and a center punch, you literally line the center punch up with your mark. In this case, the transfer punch does a pretty good job of leaving a divot there. And then you just literally push down. And you get a center punch. So that'll usually take any, 3-30 seconds drill. And then you can start a hole from there. I actually already center punched the other one as well. So we took the tact of tracing directly onto the aluminum here. On this one, I will cut this out with a pair of scissors and transfer it onto aluminum by tracing the paper, because I've already done all that work. Safety glasses are on. Time to cut some plate. I think everybody will get a big kick out of my bandsaw setup. Like that. There we go. 2 rough cut plates. You can see that hole is like way off, so we'll have to see if that fits. But yeah, we'll confirm fit on everything and then start cleaning these up. So off the bandsaw, parts are usually pretty rough. There's a whole bunch of different ways to finish parts like this. I tend to use a hand file. You can really get straight edges straight because files are, by nature straight. I tend to be able to follow these filleted lines a lot better with a hand file than with a power tool. I usually end up cutting into material that I don't really need to. So here's starting to get closer with this one with a hand file. This is just a rough file, but you can see that you can get some pretty straight edges. I actually started on the triangular shape too. So what I do to finish these parts is I have this really cheap, super cheap Palm DA sander that I got on Amazon. Uses a ton of air. It's not bodywork friendly at all, but it does the job for aluminum parts. So usually just do it in my lap. I wear a respirator because you don't want to inhale all those aluminum particles. So let's give it a shot. I'll show you guys how it goes. Do I sound like Darth Vader now? Second day, haircut. We're gonna test fit the 2 brackets, the one on the truck and then the one on the PDM. And then we're gonna cut a piece of tube and TIG weld them together. Pretty much done. Here's our PDM with rib nuts. Bolts fit in there. It's perfect. And then over on the truck, we've got our little triangular bracket. Fits in there pretty well. So that's good. So let's cut a piece of tube to, I think, probably the depth of these rib nuts plus some. Probably gonna have to make sure we can fit this bolt in behind it. This is what bolts to the firewall. So let's take this little piece of aluminum intake tubing and cut it to, I don't know, 1.5 inches maybe? We'll measure it up. One trick, got to keep everything clean. I think everybody knows that, but I bought a whole bunch of these stainless steel brushes and they end up going everywhere, right? I use them for a whole bunch of stuff, but I only use one at a time for aluminum, and it's all I use it for. So I mark it with a silver Sharpie and I leave it over near my TIG welding bench. You don't want to use the same brush for all kinds of materials and then use it on a piece of aluminum that you're going to weld, because you'll get steel in there that's left in the bristles, etc. So one brush at a time for aluminum, mark it, set it over near your TIG welding bench, and don't use it for anything else. Well, here we go. A little bit of burn through there. First weld's always better, right? Not too shabby. But getting in here, I should have known. I've done a piece like this before where getting into the nooks and crannies, there's a couple decent runs there, but this is one of the ones where you're happy that no one's gonna see it. But yeah, I think this will work out. Let's get it all fitted up. Well, there it is. It's got 2 extra holes. I drilled these for the bolts, so you can get access with a 12mm deep socket. So slide it in there, and you can tighten it up. You can also get them in as well if you hold the bolt from the backside and just feed the socket through. You can grab it and tighten it up. So let's put the PDM on. There's the PDM in place. Looks like we lucked out a little bit with the heater bracket over here, but think that'll work out pretty well. You can see I already got, these are the two cables that come from the back of the truck. I did run a negative all the way back up to the battery. So this one will stop early and just go to one of these terminals here. Really nice unit. I really like them. Haven't really had a lot of service time with them, but I like the features. I'm not worried about putting it next to the heater circuit at all because it is waterproof once you put the cover on there. Or water resistant maybe. I don't want to falsely advertise for it here. But that's it. We'll get it all wired up and call it good. Hopefully never see it again. Thanks for watching, everybody.